Hi, my name is Ameera Zyra binti Muhammad Azrin. My matrix number is 243-03832. I am from group M3A and my labs partner is Muhammad Alif Hakimi bin Muhammad Rani. So today, I will be explain the experiment that we are doing, which is projectile motion. So the aim of the experiment to study how projectile move when it launched at different angles. So in this experiment, we use a projectile launcher to launch a steel ball at a certain angle. So we can measure the distance traveled and also height reached. From this experiment, we can see how the angle of projection affect the range, time of flight, and also maximum height of the projectile. So as for me, I think the best angle of projection to start the experiment is at 45 degrees. Theoretically, when projectile launch at 45 degrees, it gives a maximum horizontal range when air resistance is neglected. Additionally, starting with this angle also makes it easier to observe the centrifugal motion and compare with a experimental result and also theoretical prediction. So one of the accurate way to measure the height of projection is by using a meter ruler to measure a vertical distance from the point of projection to the highest point reached by the ball. Alternatively, a vertical scale placed near the path of the projectile or video analysis using the slow motion recording can improve accuracy by reducing human error. So the time taken for the projectile motion to reach the maximum height can be determined by using the high-speed camera or video recording, and also the video can be analyzed by frame to frame to identify the moment when the vertical velocity becomes zero. Another method is to measure the total time of flight and divide it by 2, since the time taken to reach the maximum height is half of the total flight time for a symmetric projectile motion. So from the theoretical physics point of view, the type of material of the ball does not affect the range and also height of the projection. This is because in ideal projectile motion, only the initial velocity, angle of projection, and gravitational acceleration affect the motion. Mass and material are not included in the equation when air resistance is neglected. Although theory predicts no different in real experiment, there are still significant discrepancies between the result obtained using steel and wooden balls. This is due to air resistance, difference in mass, surface texture, and also shape, and experimental errors. A steel ball is denser and more compact, so it is less affected by air resistance compared to a wooden ball. As a result, the steel ball generally give the results that are closer to the theoretical values. In conclusion, this experiment demonstrates the principle of projectile motion and highlights the difference between theoretical assumption and also real experimental condition.